All right, so now we're going to continue with example 2. And the way example 2 differs from example 1 is that we are now dealing with a set of ordered pairs. We are dealing with some data, discrete, unconnected points. So you might be wondering, how am I going to be able to find the area under something that's not connected? So let's just kind of look and see what that might look like. So notice I've got these columns here, time, velocity, time, velocity. Time is going to represent our independent variable, or our x. Velocity will be y, and so we have another xy. Okay, so these are basically ordered pairs. We have one at 0, 0, we have one at 1, 12, another one at 2, 22, and then one at 3, 10, and then 4, 5, and these points are just going to sort of bounce around. Discrete. Okay, the way we determine the area under that discrete sort of unconnected data is we let those y values be heights of rectangles. So like this, for example, would be one rectangle. And this up here would then form my second rectangle. And then this here would be my third. And then my fourth. And then my fifth. And so on. Okay, and then just all the way down the line. And so we would have all of these rectangles that would help us find the area under those discrete set of data. So that's sort of what the picture would look like. You don't have to draw that. I just wanted you to see kind of what we're doing. And then also I want you to notice that the x's are measured in seconds and the y's are measured in inches per second, since they are velocity values. And so when I'm doing the base times the height of these rectangles, so base, of course, would be the distance between x values, or the seconds, and the height would be the velocity values, using those velocity values, which are in inches per second. So when I go to do my base times height calculation, it's going to be seconds times inches per second. And so the interesting thing about this is that I end up with just inches. The seconds cancel out. And inches are what we use to measure distance, at least in this particular context, because we're dealing with model trains that don't travel everywhere or too far, so we use inches. So I want you to notice that when you find the area under velocity, you end up with distance. And then if you could kind of think back to our chapter 3 or 4, we talked about how velocity is the derivative of position, or distance. So it seems as though that finding the area under some data is doing the exact opposite of finding a derivative. Because if you find the derivative of position or distance, you get velocity. But when you find the area under velocity, it goes back to distance. So just keep that in mind. You don't really need to understand that thoroughly today, but that concept is going to reappear later, so just keep that in mind. Okay, all we are trying to do here is just go ahead and find the distance traveled by the engine using 10 subintervals of length 1. So let's just look and see what our subintervals are. Again, for the intervals, we use the x values. So the first interval is from 0 to 1. The second interval is from 1 to 2. The third is from 2 to 3. The fourth from 3 to 4. The fifth from 4 to 5. The sixth from 5 to 6. The seventh from 6 to 7. The eighth from 7 to 8. The ninth from 8 to 9, and then the 10th from 9 to 10. Also notice the intervals all have the same distance of 1 between them, which is helpful because those distances between x values, that's what forms the base of the rectangle. So base of the rectangle is distance between x, just like it was up here in example 1, distance between x. And then the heights are basically the y values. Our y values are our heights. And then in part A, it asks for left endpoint, and so we use the left y value basically to be our height. So for part A, I'm just going to then add up 10 areas of base times height plus base times height plus base times height 10 times. And I'll begin with the first interval, which goes from 0 to 1, and the left endpoint would be at 0, and that height is at 0. So the base is 1, but the height is 0. And then for the next interval between 1 and 2, the base is 1 because that's the distance between them, but the height is 12 because that's the left endpoint's height. And then for the third one, it's between 2 and 3. The base is 1, that's the distance between them, and then the height is 22 because it's associated with the left endpoint. And so on and so forth. So then I'll use the 10, and then the 5, the 13, the 11, the 6, the 2, and the 6. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there we go. We have all of our 10 areas or rectangles. I need to now multiply all that and add that all together. And when I do, I get 87 inches. So that is the total distance traveled, or at least an estimate of the distance traveled by this model train in the first 10 seconds. Now I'd like you to go back and do part B. And if you do, you also end up with 87 inches. So I'd like you to go ahead and try that and see if you can get that right answer. And when you're ready to do so, move on to example 3.